Very good evening, everyone. Very good evening, all. Welcome to our 21 days masterclass series on autonomous vehicle. I hope you are all doing well and had a productive day. I hope I'm audible right now. Yeah. Very good evening, everyone. I welcome you all for engage your learning experience with Pantech learning anytime, anywhere, at any places. We are always supporting to the students in a technical way. And also our main vision is to help the 10 million students easily learn the technology. So today is day 5 on this 21 days masterclass journey on autonomous vehicle. So let's talk about the load ground truth signals to the label. So yesterday we discussed about how to load the video sequence and leader point cloud sequence in Groundtruth Labbller app. Now we are going to define the labels and we are going to define the objects. Detected the objects in a selected segment of the frame to show how this label working. So first of all, we should know about that. What is labeling? So here this is the video sequence labeling and this one is the point cloud sequence labeling. I will tell you one by one. So first, mainly this labeling step, it's specifying the categories. It's specifying the classes of objects you want to identify in that video or any point cloud sequence video. For example, you might define label the such as you might define the labels such as the cars or pedestrians or a bicycle, etc. So once you have defined the labels, you can apply them to some specific frames in that sequence. That means the marking or annotating that objects in the frames that according to the defined labels. So for instance, if there is a car in a frame, you would label it as a car. So this is what the labeling. So to create the label definitions which contain information about the labels marked on the signals. So before we get into how to create a label definition, so first we should know about this one. What is that? That is ROI, region of interest. So what is this region of interest? ROI stands for a region of interest. It's like a highlighted area in an image or a signal that we want to focus on because it's important for our analysis. So we might use to find out the objects and find out the track movement or measure something specific within that area. So this is what the ROI, and let's talk about the ROI label types. So what are the types here? It has a rectangle and cuboid. So rectangle in the sense this label type allows you to draw the bounding boxes. It's like a square boxes label around objects like the vehicles. As I said earlier, in image signals, you draw the label of this type as a 2D rectangular bounding boxes. In case you have a point cloud signals, you draw the labels of this type is a 3D cuboid bounding boxes. So as this is like, so it's like a 3D cuboid bounding boxes and this is like the 2D rectangular bounding boxes. This is that one type and next one is the rotated rectangle. So this label is used to draw the 2D bounding box labels around objects in an image that are rotated. Next one is the projected cuboid. You can use this label to draw the 3D bounding box labels around the objects in an image such as vehicles. Next one is a line. So this label type, it enables you to draw the linear region of interest to label the lines such as the land boundaries like that. Next one is the pixel label. So you draw the pixels to label various classes such as the road or a sky or any semantic segmentation. So next type also that is a polygon. So this polygon label allows you to draw the polygon labels around the objects. You can label the distinct instances of the same class. So this is what the ROI types. So now we want to create our car label first. So first we want to open that MATLAB software here. So I'm going to open the MATLAB software. So it will take a few seconds to open. So first we have to create an ROI label definition for labeling the cars in the signal frames. Yesterday we discussed about how to load the videos in the Groundtruth Labbller app. Now we are going to create an region of interest label definition for the labeling cars in the frames. So go to apps. Under the automotive section, here you can see the Groundtruth Labbller app. Click on that app. First, I'm going to, okay. So this is that app. Yesterday, we load that videos and point cloud. So now I'm going to open that one. So go to this open session. I'm opening this one, Groundtruth labeling session. Yesterday, I saved that video. So that is why I'm opening here. It will take a few seconds to load that same file, same sources, video source and LiDAR sequence source. Yeah. So now I'm going to create the label. So first we have to create the car label. So on the ROI labels here on the left plane, so click the label. So click the label here. So once you click this label, here you can see one window that is define the new ROI label. So first we have to give the name of the label. So on the ROI label left plane, go to click label and create a rectangle or a cuboid label that is named as a car. So I am going to select that one rectangle cuboid. I am going to give the name is car. So go to group. So in this group, from the group list, select the new group and name the group as a vehicles. So I am going to name this one as a vehicles. The group name is vehicles. Once you click OK, so the vehicles group name appears on the ROI labels tab with the label car under it. Now I am going to do that one. Here you can see. So this is the group and this is the car label. So here the car label is drawn differently on each signal. So on the video, the car is drawn as a 2D rectangular bounding box of the type, and on the point cloud, the car is drawn as a 3D. So that is why this is bounding box and this is the 3D cuboid bounding box of the type of cuboid. Now we are going to create the sublabel. So for that we go to our slide. So now we are going to create the sublabel in our app. So this is that vehicles and car. So under this group we have a car label, and under this car label we want this brake light label. So for that we need to create a sublabel. So what is a sublabel in this sense? Sublabel is a type of a ROI label that correspond to a parent ROI label. So that means this is the parent ROI label and this one is the sublabel. That means each sublabel belongs to be a child of a label definition that is in the ROI label types. So for example, in a driving scene, a vehicle label can have the sublabels for headlights and license plates or a wheels. So to create a sublabel definition for the labeling the brake lights of the labeled cars. So first we have to select the parent label of the sublabel. On this ROI tab, click the car label to select it. So on the ROI tab, click the car label to select it and click the sublabel. Here you can see. So create a rectangular sublabel named as a brake light. That is, the cuboid sublabels are not supported because this sublabel it applies only for the video signal only, and then click OK. So the brake light sublabel appears on the ROI table under the car label. So the sublabel and parent label have the same color. So now I am going to create that sublabel. So for that, this is that sublabel. I am going to name this as a brake light. This is a brake light. I am going to select that rectangle one and click OK. So here you can see this is the group list and this is the car label, and here this is the sublabel. So we successfully created that one. Now we are going to create the attributes. So what is that attribute? I'm going to the slide. So now I'm going to create the attribute. So this attribute adds some specific details or some specific characteristics to an object or a region, such as its color or a size or whether it is turned on or turned off. So for example, in a scenario where the cars are labeled in the driving seat, attributes could include the number of doors as a numerical value, or it's either color, that means a string value, whether the vehicle is in motion, that is a logical value, or to make the model, that means a list of the options. So you can define the ROI attributes of these types: numerical value or a string value or a logical value or a list. So list in the sense it specifies a drop down a list attribute of the predefined strings such as make or a model of any vehicle. So now we are going to create the attributes in app. So first create the attribute to describe whether a labeled brake light is on or off. So for that we need to create that one. So go to the ROI label in the left plane of the app, Groundtruth Labbller app, and select the brake light sublabel and click the attribute. So select the brake light sublabel and click the attribute. In the attribute name box, just type is on. So set the attribute type to logical and leave the default value set to the empty. So I will show you that one. So go to this one. Select on this and go to select this attribute here. So once it's select, we are going to give the name. This is the attribute name box. So I am going to just type is on. So just type is on and set the attribute type to the logical. After this, default value set to empty or optionally provided description also. And then you click OK. So once you click this OK. Once you click this OK, go to this brake light and here you can see the attribute is on. So the attribute box for the sublabel now contains this is on attribute. So that this is the way you are going to create the attribute. Now we want to create the scene labels. So for that again I am going to the slide. So now we are going to create the scene labels. So what is that label? What is that scene label? So scene label, it provides the extra information about the overall conditions or events in a scene. It's like describing the lighting or a weather or a lane changes or happening across all the signals. Now we are going to create a scene label to the signal frames. So for that, I am going to open the software. So in the left plane of the app, select the scene label tab. So select the scene label tab and click the define new scene label, and in the label name box enter a scene label named as a date time. So I already created this one. I'm going to delete. I will show you again. So go to this define a new scene label, and this label here you can the label name box and enter a scene label named as a date time. So I am going to use the date time and change the color of the label settings, label definition to the light blue to reflect the nature of the scene label. So going to select this one. I'm going to select this blue, light blue. So change the color of the label definition to the light blue to reflect the nature of this scene label. So under the color parameter, you have to click the color preview also. Then click OK to close the color section window and leave the group parameters set to the default of none. I am going to click OK. So here you can see this is the scene label. So successfully we created that a scene label. And now we are going to verify the label definition. So for that we need to go our slide. So verify the label definitions. First we have to verify the ROI label tab. So check if there is a vehicle group within a car, a label of a type that is a rectangle or cuboid. Ensure that the car label contains a sub-label named as a brake light, and confirm that brake light sub-label it contains an attribute is on. So let's check again. Go to RI. Yeah. So we have a vehicle group name. Under this we have a car label and brake label. So the attribute is type is on. And go to the scene label and look for a light blue scene label named as a date time. Yeah, it's that. So to edit or delete a label definition, right click on that name and select the appropriate options. To save this label definition for the future use, you go to the label tab and select the export. Here you can the export from this export to file, or under the label definition go to file, so that this session and this changes will be saved for our future reference. So this is all about how to create a ROI labels and scene labels, and how to create attributes also. Now we are going to do the automation. So that means a label video using the automation. Again, I am going to open the. Now we are going to automation. So label video using the automation. So first, label video automation, it basically refers to the process of automatically applying the labels to the objects or a region of interest within a video using some specialized algorithm. So basically this process, it significantly speed up the labeling process in situations where the manual labeling would be time consuming or impractical. So that is a label video automation. So first we have to select the time range of our video sequence, and we have to choose the label and algorithm and move on. And next we are going to select the signal and initiate the automation and perform the labeling. At last we have to run that automation. Click the run option in that app. Next we are going to review and adjust that labels and manually adjust them if any necessary to improve that accuracy. Once satisfied with that labeling, click the accept to close that automation session and apply the labels to the specified portion of the video. So by automating the labeling process, you can efficiently label the objects in a videos, that reducing the manual effort required while maintaining the accuracy. So let's go back to our demo. So this is that Groundtruth Labeller app. So first you have to select the time range. So go to this start time. So in this start time, so start time is, I'm going to select the just 8 to 10 seconds. So current time also 8 and end time is 10 seconds. This is my end time. So use a car label to label one of the cars in a portion of the video. So to assist with the labeling process, use one of the built-in label automation algorithms. So I will explain that algorithm separately. So select the time range to label, specifying an interval 8 to 10 seconds during which the car in front is closer to the ego vehicle. So first I am going to select this one. So select the car label and just type the start time as 8 to 10 seconds. So here you can see the 8 to 10 seconds. So this 8 to 10 seconds, the range slider automatically goes to that 8 to 10 seconds once you change this start time, current time and end time. So this app displays the signal frames from only this interval only. Here the automation algorithms apply to only this intervals to expand the time range to fill the entire playback session. So now select the label that you want to automate. In ROI label, so select in ROI label, select the car label, click that car label and select the algorithm first. I am going to use the temporal interpolator. So temporal interpolator. So this algorithm, it exactly estimates the rectangle ROIs between the image frames by interpolating the region of interest locations across the time range. So I am going to click this one, select this one and go to select signals. So select the signal that you want to automate. Which signal you want to automate. So I am going to select the signal first only for the video signal and then click OK. So this algorithm, it supports labeling of only one signal at a time. So the point cloud signal uses a different automation algorithm. So I am going to use this video sequence only and click automate. So click this automate. So this app, it promotes you to confirm that you want to label only one portion of the video. Yeah, here you can see only one portion of the video. An automation session for the video will be open once you click that automation. So the right plane of the video, the automation session algorithm, it displays the algorithm instructions. So this is the instruction of the algorithm. At the start time of the time range, click and drag at the start time of a time range, click and drag to draw a car label around the car in the center of the frame. So first, at the start time of the time range, going to click and drag to draw a car. So just start time, I am going to draw a car here. Car label around the car in the center of the frame. So for this algorithm, you can draw only one label per frame. So this is the car. Here you can see this is the car. So we successfully labeled that one. So for this algorithm, you can draw only one label per frame. So this labeling the car that would require a separate automation session. So by default, the car label appears only when you move your pointer, your cursor over it. So to always displays that labels, go to the app. Here you can, this one is the show labels, show ROI labels. Okay. So now we are going to drag the slider to the last frame also and draw a car label around the same car in this frame. So I am going to drag the slider to the last frame. Now I am going to draw the car. So delete this one. Again, I am going to draw this car. So now it's optionally to improve. Why means it's optionally to improve the automation results, the label, the car and intermediate frames. So start frame and end frame. So click run and the automation algorithm applies the car label to the intermediate frames. So drag the slider to view the results. If necessary, manually you can adjust the labels to improve their accuracy. Now I am going to run this one. Yeah. So when you are satisfied with your results, you click the accept to close this session and apply the labels to the portion of the video. I am going to accept this one. Yeah. Now run this one here. So it's successfully created our label here. Now we are going to, the same way we are going to create the label point cloud sequence using the another automation. So in this video sequence, we are using that temporal interpolator algorithm. So I will explain that temporal interpolator algorithm. So what is this algorithm? Why we use this? Basically, this temporal algorithm is a type of the computer vision program. So that looks at changes or any patterns in a video over the time. It helps to understand the things like movement or patterns and changes in a video by analyzing the consecutive frames. So this is what the temporal algorithm. So the same way we are going to create our LiDAR sequence also. Now I am going to do that LiDAR sequence. So for point out the labeling a point cloud sequence, it involves the automatically labeling objects in a series of 3D point cloud frames. So first we have to set the same way. First we have to set the time range and select the point cloud and choose the label and algorithm and select the signal and initiate the automation, and we have to label the object and we have to adjust the object label and copy and paste the label. Then we have to run the automation and accept the results. So by automating the labeling process, you can efficiently label the objects in a point cloud sequences. It will reducing the manual effort while maintaining the accuracy. So the same way I am going to create here. So use a same car label definition from the previous procedure to label a car in the point cloud sequences. So to assist with the labeling process using some automation algorithm. So in this example, our label the ego vehicle, which is easier to see in the LiDAR point cloud sequence than the front of the car. So first we have to verify the time range. So the start time will be 8 to 10 seconds. So first we have to select this LiDAR sequence, and in the ROI table, go to this car label definition. On the label tab of the app tool strip, you have to select your algorithm. So I am going to select this algorithm to point cloud temporal indicator, and then go to signals. I am going to only for this LiDAR sequence only. So just click the LiDAR sequence. Once you give the LiDAR sequence, let's click that automate. So automatically this app, it promotes you to confirm that you want to label only one portion of the point cloud sequence. And here the automation session for the point cloud sequence, it opened here. And here you can see the right plane, the point cloud instructions, algorithm instructions. So at the start time range, draw a car label around the ego vehicle. So zoom in on the car. You can using either the scroll down or either use the zoom in button at the top right corner of the frame. So this is the zoom in and zoom out button. So if you want to close to the ego vehicle, or you can also use a pan button to center the car in the frame. So first on the ROI labels in the left plan of this app, click that car label. So click that car label and drag the gray view cuboid until it highlights the ego vehicle. So drag the, I'm going to zoom in out. So drag the cuboid until it finds that ego vehicle. So this is our vehicle. I am going to place this one. Wait. Now I am going to place my cuboid around here. So this is the way you are going to find the ego vehicle. So just click this OK. So click the signal frame to create the label. So click the signal frame to create the label. So the label snaps to the highlighted portion of the point cloud. So that is the car. So this is the car. So adjust this cuboid label until it fully encloses the car. To resize the cuboid, click and drag one of the cuboid faces. So just you can resize. To move the cuboid and hold the shift and click and drag one of the cuboid faces. Now we are going to use some projected view to adjust the cuboid label in a top view and side view and front view simultaneously. So under the LiDAR tab, here you can see the projected view. Just click this one. So this is the projected view. Here you can see the top view and side view and front view. So this now we have to click the cuboid and press the Ctrl C and copy it. Then drag the slider to the last frame and press the Ctrl V. So I am going to copy this one and go to the slider, go to the last frame and paste it here. Now we are going to run this changes. For that, go to automate and here you can run. So once you click this run, the automation algorithm, it applies a car label to intermediate the frames. So drag the slider to view the results. If any change is necessary, manually you can adjust the labels to improve that accuracy. So when you satisfied with the results, click accept and close to the session and apply to the labels to this portion of the point cloud sequence. So this is the way you are going to create the labels in video sequence and LiDAR sequence. So again, we go back to our slide. So this is our today's task. You have to load any one type of a signals into the Groundtruth Labbller app, a video or a LiDAR point cloud sequence, and you have to label the brake light. So now we have learned about how to label the car label in a video sequence. The same way you are going to create the label, the brake light in a video sequence. So this is your task. And this is all about how to use this Groundtruth Labbller app and how to load the video sequence and point cloud sequence in that app, and how to label that video sequence, how to define the car label, and how to define the LiDAR sequence in a car label. So these are all the things we learned today. I hope you can understand this session. Thank you so much. Thank you for your active participation.